Okay, so the first question is a work question. So it's saying this mass is being pushed or pulled, whatever, to the right, and the friction of this surface is 0.250. The mass is 20.5, and the work that's being done on this system is 1,000 joules. So, and the question asks, what is the distance traveled? So we are trying to find D here. Well, we have work, and so we can do that. So work equals force times distance, right? Well, what is the force acting on it here? Well, it is friction that's going against it. So 1,000 is going to equal our friction, which is 0.250 times mg 20.5, 9.81, right? The mu mg, that's our friction right there. And then it is times the distance traveled, and that is our variable that we are trying to solve for. And we can plug that into our calculator, numeric solver, and you should get something to D equals 19.9 meters. So pretty much work equals force times distance, and the force here is the frictional force that's acting against it, and you just multiply it by the distance, and that's the variable we're trying to find. Okay, the next one is asking for this distance again that it's traveling here at the top here though, and it is going past an incline, and the work stays the same. Work equals 1,000 joules. So what can we do to set this up? Well, we can start with 1,000 joules. It's going to equal all of the forces acting on it, right? So first we have this one, which is 0.2, our friction at this stage here, times m, which is the same, 20.5, mu mg, right? And then it's times our distance that it travels, which is 5.00. And it's going to be plus, what other force does it exerts on it or happens to it? Well, it is rising up this ramp here, so it's gaining potential energy. So we're going to gain, which is 1.40, because that's the height, times mg, which is 20.5 times 9.81, plus what other force? Well, it's this frictional force here, and we are trying to figure out the distance. So we can, let's just go at the bottom. This comes to mu, which is the same, mg 20.5, 9.81, and it's times the distance that it travels, d. And if we plug that into numeric solver, our d comes out to 9.29 meters. So that is how to do one like that. Okay, the next question is pretty much the same thing, except at the end there is a little spring here, and it is asking what is going to be the x here. How much it compresses, the length that the spring compresses, as you know. So we can pretty much do the same setup. So it's going to be 1,000 joules, we don't need joules, equals, right, our friction here, 0.250 times 20.5 mg, right, and the distance is 5.00, plus our potential energy gained, which is 1.40 times 20.5 times 9.81 mgh. Sorry about that. And then we are going to be adding this that it travels here. So it is mu 0.250, 20.5 mg, and the distance that it travels here before it compresses with the spring is 6 meters. It's not going to be the distance up here at 9.29. It's going to be 6.00. So using that information, we can do our friction that it travels, right, times 6, but it's also friction goes in this whole length here. So it's going to be 6 plus x, right, because the friction goes into the spring at the bottom as well. So while it's compressing, it's also experiencing a frictional force there. So that's what the plus x is for. And then it's going to be plus our 1/2 kx squared, which is 555, and x squared. So now we can plug that into solver, and we should get 0.687 meters. So that is how to do a question like that. Okay, and then this question asks what is the final velocity here after going through this whole system here. So we're given all these things, and we can set up our equation starting with work. So our work is 10,000 joules this time, is going to equal, now let's piecemeal this, force by force. Okay, so our first one that it experiences is 0.25. It's friction, right? 0.250 mg 65.7 9.81 times our distance, which is 7.00, and it's going to be plus the distance it travels up here. So, or actually we can start with the potential energy that it gains. So mgh 65.7 times 9.81 times the height, which is 0.75. Then we can add our friction that it experiences going up this ramp. So that's 0.330 times 65.7, 9.81, right? And then it's at an incline angle here, so it's going to be cosine 25, right? And the distance it travels, well, we can use the height over sine theta formula, so 0.75 over sine 25, and this is just a shortcut to get the hypotenuse right here. Other ways you could do it, just arc sine, whatever, all that. So that's just one way to find this hypotenuse, because that's the distance it travels. So that's what this is right here. Then it is going to be plus, what other force is it experiencing? Well, it's experiencing this force that it travels here. So it's going to be, it is mu, which is 0.050 mg. M is 65.7 times 9.81 times the distance it travels, which is 2. Perfect. Plus the final thing is the kinetic energy, because we're trying to find VF. So 1/2 m, which is 65.7, and it is V squared. And we can use our numeric solver to find that V final is going to equal 15.6 meters per second. So that is how to do a question like that.